Hi everybody, in this lesson we're going to be looking at quadratic functions but in vertex form. So in the beginning of this unit we talked about the importance of the vertex of the parabola. So when we have a parabola, the vertex is that turning point. The vertex is right here. It's the turning point. It's that minimum or the maximum of the parabola. And our parent x squared function has a vertex of 0, 0. It passes through the origin. So we can use our transformations from the last two lessons to figure out what our new vertex is going to be. So this lesson is focusing on the vertex because we've spent a lot of time focusing on the zeros. Now we're going to give some attention to that other important point of parabolas. So let's look at this first graph here. Y equals x plus 3 squared minus 4. So let's take a minute and think of the transformations here. This is inside, so I see a plus 3, but I need to think the opposite. So I'm going left 3. And I see a minus 4 on the outside, so I'm going to go down 4. So thinking of my transformations, I started at 0, 0, and I moved left 3, down 4. So if I start at 0, 0, and I go left 3, down 4, there's my new vertex. My new vertex is at negative 3, negative 4. Knowing these transformations can tell us the vertex just by looking at this equation. So let's look at this one. My horizontal shift is going right 2, right? This is the opposite, right 2. And this is normal, up 1. So we start at 0, 0 because my parent function is x squared, and I'm going right 2, up 1. That's the new vertex of this parabola, 2, comma 1. So I'm just translating my parent x squared function to get my new vertex, which involves these horizontal and vertical translations specifically. So I don't see an inside shift, so I'm not moving left or right at all. I'm just going down 5. I'm going down 5. So if we start at 0, 0, I don't need to move left or right at all. I'm just going 1, 2, 3, 4, 5. I'm just going down 5, and that's my new vertex. I didn't move left or right at all, but I did go down 5. So using these transformations, we're going to develop this thing called vertex form of parabolas, which is actually very, 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 very powerful and important to work with. So it reveals a lot of information about these parabolas here. So we've worked with standard form, ax squared plus bx plus c. That's when we can use the quadratic formula. Here, we're going to use a different form which should look familiar. It should look familiar like someone already completed the square, which is actually going to be in the next lesson, not this lesson. But if someone already completed the square and got you set up here, this is called vertex form. We call it vertex form because you can quickly tell me the vertex. It's the opposite, right? I'm going left 3, down 4. So my vertex is left 3, down 4. That's the vertex of the parabola. And that's why we call this vertex form, is because you can quickly tell me the vertex. So 1, 2, 3, 1, 2, 3, 4. Here it is. Is it a maximum or a minimum? So does this parabola open upwards? Is it concave up or is it concave down? And the number that tells us that is the leading coefficient. The leading coefficient is positive. Remember, the positive leading coefficients open up, but if I put a negative in front of it, a reflection occurs and I open downwards. So this vertex is the bottom of the parabola because it opens up. So I'm going to say the leading coefficient is positive. So the parabola is concave up. I have a concave up parabola here. Therefore, this vertex is a minimum. It's at the bottom of the valley. The vertex is a minimum. If I was concave down, that vertex is at the top of the hill. So we can quickly get the vertex, and you can tell me, is it concave up or concave down, based on the leading coefficient, based on this number outside of the set of parentheses. Find the x-intercept. So let's think about it. What's another name for an x-intercept? Those are the zeros. Find me the zeros. So let's find the zeros, set it equal to 0. That'll tell me where my parabola crosses the x-axis. This will be my zeros, my roots. These are the roots of the equation, of the function. So it looks like I can use inverse operations here. I can use inverse operations. So let's do that. Let's add 4 to both sides. X plus 3 squared equals 4. Well, then we take the square roots. That's where all of our good quadratic equation solving skills from Unit 8 come back into play. And then we can subtract 3. So x equals -3 plus or minus the square root of 4. But wait a minute, I know the square root of 4, that's 2. What number squared is 4? 2. So I can actually tell you what my zeros are. My zeros are -3 plus 2, -1, -3 minus 2, that's -5. Those are my zeros. That's where I hit the x-axis. I hit the x-axis at -1 and -5. So now we're ready to sketch a graph. I know my zeros are -1 and -5. I know my vertex. I know my vertex is -3, -4. And once you have these 4 points, you can finally make me the parabola. That's not curvy enough. We want this to be nice and curvy. Once you have 3 points, you can finally draw in the parabola. I used my zeros, which I'll highlight in blue here, and then my vertex, which is here in red. So the nice part of vertex form is you get the vertex, and then you can always use inverse operations to solve for the zeros. What's the range of this function? How low does it go? Are my y values, well, the lowest they go is -4. And they are always bigger than it. Look, it opens up. From -4, I go up. So my y values are bigger than or equal to -4. If it was opening down, I'd flip that inequality. But it always ranges your y values. It's your outputs of a function. So go to your vertex. It's always going to come from your vertex and decide, do you open up or do you open down? Who's the axis of symmetry? Well, that's that line going down the middle of my parabola. There it is. That axis of symmetry is an x equals line. X equals, well, what does it equal? Where's my vertex? X equals -3. My vertex is the point -3, -4. So notice the x value gives you your axis of symmetry. The y value helps you find your range. So the zeros are really important, but also the vertex is really important because it gives us a lot of good information about a parabola. And we can get that information just by looking at an equation, which is the nice part here. Let's do this all again. Let's do this all again, but with a different parabola. So consider the function. Consider the function -2 x minus 5 squared plus 8. So who's the vertex? All right, what horizontal and vertical shifts are happening here? I'm going right 5, up 8. Right 5, up 8. There's my vertex. Is it a maximum? Am I concave down? Or is it a minimum? Am I concave up? Well, that vertex here depends on the leading coefficient. I'm going to say the leading coefficient is negative. The leading coefficient is negative, so the parabola is concave down. It's opening downwards. The parabola is concave down. So if I'm concave down, do I have a maximum or a minimum? If I'm a frowny face parabola, that vertex is the king of the hill. It's a maximum. So this leading coefficient here is very powerful. The leading coefficient determines, do you open upward or do you open downward? Find the x-intercepts. Well, I want to find the zeros. I want to find the zeros of this function here. Let me set this equation. Come on, Sparky, you got it. Let me set this equation equal to 0. So here we go. Subtract 8. I know you want to distribute that -2, but remember when we do inverse operations, we can't. We can't distribute it. We need to divide it over. We need to divide that over. So now I take the square root to undo squaring when I do my inverse operations. The square root of 4 is 2 plus or minus 2. And then I add over 5 and get x equals 5 plus or minus 2. 5 plus 2 is 7. 5 minus 2 is 3. Those are my zeros. X equals 7 and x equals 3 are my zeros. So let's sketch a graph now. Now that we've got all this information, we can easily draw a graph. I know my zeros. Where do I find my zeros? On the x-axis. 1, 2, 3, 4, 5, 6, 7. I find my zeros on the x-axis, and our vertex is at the point 5, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 5, 8. There it is. Clearly, this parabola has to open downwards. Clearly, this parabola is concave down. There's my sketch. I sketched that parabola without having to pick up a graphing calculator. I had to do some algebra and some thinking, but I was able to graph that parabola without picking up a graphing calculator. State the range, state my y values. Well, the highest they go is the vertex of 8. My y values are what? My y values are 8's the highest they can go, so I have to be smaller than or equal to 8. Y has to be smaller than or equal to 8. The axis of symmetry, who's cutting this parabola in half? Well, it's x equals positive 5. How did I get that? It's from my vertex. It's the middleman in my table. It's that vertical line that makes a mirror image of my parabola. One more part and we're done with this lesson. So write an equation of a quadratic of a parabola whose vertex is 2, -4. So let's think about this. So I've got 2, 1, 2, 3, 4. There's my vertex. So y equals something squared, right? It's a quadratic. It's an x squared function. It's a parabola. Well, how do I start from 0, 0 and end up at 2, 4? Well, I have to go right 2 and down 4. So how do I go right 2 and down 4? Well, the inside is my horizontal shift, right 2, and then I need to go down 4. Right 2, down 4. How many functions exist? Well, I told you nothing about the leading coefficient. I told you nothing that goes in front of there. It could be a 1. Maybe it's narrower and has a 2. Maybe it's really narrow and has a 4. Or maybe it's wider. Remember, 1/2, 1/3, 1/4 makes the parabola wider. Or we could get even crazier and reflect this parabola. We could have a -1 in front of it and have this parabola open downwards. So I did not tell you what the leading coefficient there was. So we're going to just assume it's 1. Let's just put a 1 there and pretend like we're good to go. So how many quadratics exist with this vertex? A whole bunch. This number out front determines a lot of things about the parabola. And on that note, I'm going to end the video. But the key thing is here, if you have y equals, I don't know, x plus 7 squared minus 1, you need to quickly tell me the vertex is left 7, down 1. Left 7, down 1 is my vertex. It's the opposite and then the same. Opposite of the inside, the outside stays the same. That's how you can quickly get your vertex. And in the next lesson, we're going to be completing the square to make this happen. And I can't wait to complete the square again with you. See you in the next lesson.